Hello and everyone, welcome for another episode today on my channel, which is focused on CICD. And today we're gonna attack our CICD pipeline and try to impersonate ourselves, right, Richard? What are we going to do?
Hi, Johannes. Thanks for having me. So today I'm going to showcase attack on GitHub Reusable Workflow, especially on the keyless signing, which is using SIGstore, and many famous repositories using it. And I'm also going to demo on one of the famous repository.
That sounds pretty interesting because I think it is important to understand what security in your CI/CD chain means, and I think we're going to talk about that as well. But before going into that, I told you there is a bunch of stickers over there, and as I do recordings with people, I always give them the choice, as long as I have space and as long as I have stickers, to choose a sticker that they want me to put on next. Given you're an AWS DevTools hero, I thought I'm gonna offer you the community.aws sticker that I have.
That's awesome.
That is one. And another option is the user group sticker, AWS user group, right? Sticker. And then last but not least, and I think I have a feeling which one you're gonna choose, is the pre-invent hike sticker from 2022. Now you need to choose which one goes up next.
The user group. Yeah.
The user group. Cool. Then let me put that on after our recording. And with that, Richard, let's give a little brief into who you are. I already said you are a hero in the same way that I am, but what's your specialty and what makes you as a person?
I'm an AWS Security Hero, so I'm focusing on cloud security. In my daytime job, I am a security engineer in ExpressVPN. So what I did before I become a hero is I do a lot of research on AWS Nitro Enclave. For those who don't know what is Nitro Enclave, it's a confidential computing environment in EC2 instance. And back then, in 2020, when AWS launched the Nitro Enclave, I see the very unique potential on it. But unfortunately, the documentation on AWS side is not very good. So I decided to build my own demo project and documentation tutorial. And it started to get traction, and more people is trying to using it. And today, today's topic about supply chain security is also part of my research on Nitro Enclave. And stay tuned. I will talk about it a little bit on how it relates to Nitro Enclave around at the end of the podcast, maybe.
Yeah, and besides that, you're also a fantastic person, and I really enjoy talking to you and working with you, as we've also started as community builders, I think, kind of together. Maybe you were there before me, but you were part of one of the hike events that we did before reInvent, and I hope that you're going to be part of that one again this year.
I'm looking forward to it.
And with that, let's start diving into the topic. So, listeners on my channel should most probably have seen a session around reusable GitHub workflows. So we're going to assume that people watching this video know what reusable GitHub actions and reusable GitHub workflows are. And that is a prerequisite for understanding what the attack is going to look like, because we are in the GitHub Actions world. Before we go into the very technical, deep things, right? Why do you look at supply chain security, and what role does the CI/CD pipeline play in that for you?
Actually, this is part of my Nitro Enclave research, as I mentioned. So what I did around end of last year, I was trying to do something on the software of the running on the Nitro Enclave. So Nitro Enclave is a confidential environment that we want to process sensitive data in it. But to secure the environment, we don't just secure the infrastructure. We want to make sure the software running inside the environment is also a good software. And one way to prove that it is a good software, not malicious, is to look at the source code. But then there's a problem on linking the software and the source code. So how do I know if there is a software, is it building from this source code that I just reviewed? Or is it I'm just reviewing a source code of version A, but I'm using a version B of the software? So the linkage is all about supply chain security. And one thing I find out is about using the CICD pipeline. Get the human.
Okay, so at the let's pause there for a second, because essentially what you're saying is that means that as a user of any open source software, but also as a deliverable software that I build, right? I somehow need to be able to prove that the software that is now running in production comes from a specific piece of source code that I created, right? And this needs to be true not only for the source code that I built, but also for all other parts that are part of my application at the end, right? And this includes then open source libraries. Is that what you're saying?
Yeah, that's also the also part of the supply chain, but we're not talking about so deep today, because nowadays software uses like thousands of dependency. We don't know how the dependency is it good or bad. This is other part of the supply chain security, but we are looking at the very basic level. Is it our main software? Is it built from our source code? We don't look at the dependency yet, but we are looking at our own source code. Is it not modified?
Okay, and that's where the CICD pipeline comes into play, because I guess that attestation somehow needs to be built into this. CICD chain, right?
That's the other part of why we bake it into CICD. Because CICD is all about moving human away from the build process. So in order to like make the build trustable, make the software build trustable, we need to have a consistent CICD pipeline to do the code signing. So that's why we need to look at how we can bake the code signing process into CICD pipeline and make it not cannot be tampered with.
Okay, can you expand a little bit on what code signing means for you, and explain a little bit what that actually does?
So historically, when we want to see if a software is built by some trusted party, like the grand old day when we're using Microsoft Windows, we have many software. We can right-click the exe file and click on properties and see the signing, and then Windows will tell you this software is signed by I'm playing EA FIFA. Then the software is signed by EA, so I know it's not a pirate version of FIFA I download from some random website. It's really a FIFA that I bought from the game store. So this is the code signing. Is that in this case, EA, who built this FIFA software, have their private key. After they built the FIFA, the game, the software, the binary, they will use the private key to sign the exe before distributed. And we all know what is the public key of EA. So before we run the game, Windows can help me to check if this signing is really coming from the public key of EA. Then we know we're not playing with a other version, pirated version of FIFA, but is a genuine, real FIFA that built by EA. That's how code signing come into play.
Okay, cool. So at the end, technically, do you do that manually by calculating hashes for the different files, or how do you technically kind of do that
today? Signing is still, we take the hash of the file and we use the private key to sign it. And when we verify, we'll verify if this signature, is it match the digest of the file that I'm ready to use. So this what signing is doing. And we were going to talk about a more advanced version of not just signing it, but also giving the information of the signing. When we talk about the SIGstore environment.
Okay. And I guess that usually you would use a tool for doing that. Right?
So the interesting part is, so let's take a look of the example I just gave. So EA hold the private key. They use the tools to sign it. Maybe it's I don't know, maybe Microsoft Cert Util, something like that. They will use the private key to sign it. But the problem is, if we use the private key to sign it, where does EA store this private key? Oh, if you ask them, they will say, okay, our private key is very secure, securely stored in our CICD system, blah, blah, blah. However, we have a backup private key in our backup system. We have a proper access control procedure that only authorized IT personnel can access the private key. But then you ask, how can I trust it? If they have the backup of the private key, how can I know that the FIFA that I'm running on my computer is really signed by the CICD pipeline of EA, but not a random IT admin in EA download the private key into the laptop and then sign something else? How do I know that? So historically, we use some generic signing tools, pull the private key to sign it. But in the modern era, we start to use keyless signing, which we don't hold the key, but we use something else to prove our identity. And we, in the CICD pipeline itself, we generate ephemeral key, and then use the xdoc 509 certificate, just like the certificate that we find on the website HTTPS, and use that certificate to guarantee that who is signing this software. So simply say, historically, we are trusting the private key itself, but now we're moving to the era that we're not just blindly trusting. Okay, if I see the software signed by this specific private key, then I can trust it. We are not. We are trusting the certificate ecosystem. That's how keyless signing is gaining traction in modern CI/CD pipeline environment.
Cool, that makes a lot of sense. So now, let's move over to the attack that you have been able to simulate and that you have been also able to use against a few very well-known repositories. What is it about? Can you talk us a little bit through it, and what is the foundation for that attack?
Yeah, so what I've just said is the keyless signing and also the identity. But we still have a question on how do we prove the identity? Let's say I personally want to sign something, but I don't hold the key. So how do I prove myself? One option is to use SIGstore, which we are going to talk about. So how does it work is SIGstore contain different components. One component is called Fusio. It is a PKI, Public Key Infrastructure Certificate Authority that we all trust, and it will issue cert to different entity. So what SIGstore do is we can download the tools from SIGstore, which called cosign. So we use cosign to the command line to sign something, maybe just maybe a PDF file that I want to send to someone. I sign it, and then it will ask me to log in with either GitHub, if I remember correctly, include Google and Microsoft. So you can maybe log into your GitHub account, and then the GitHub account, the OAuth magic will go behind the scene. GitHub will send the token to Fusio, prove that, okay, this is Richard. I have already authenticated with him. He has the right password on the GitHub account, so he must be Richard. And then he will tell Fusio to, can you issue a certificate to Richard? And then, oh, by the way, before that, cosign, before I do the login, it will generate a random private public key pair. So the private key will store in my computer temporarily. And then after I log in with GitHub and they do the OAuth magic, GitHub will also send the public key to Fusio and ask Fusio to, okay, use this public key to create a certificate for Richard. And when I receive the certificate, I can use my, the cosign will use the temporary private key to sign my PDF file. And then it's all done. The private key will be disappear. And then the certificate will be in my computer alongside with my PDF as well. So then I can send the PDF file along with the certificate to maybe to you, Johannes. And then, Johannes, you can check against the certificate and see, okay, this certificate is issued by Fusio, which is as I say, we all trust it. And then to see the subject of the certificate is Richard. And Richard, why Richard have this cert? Because he has go through the GitHub login. Then you can trust this PDF file is signed by me. I don't need to give you my public key. And you don't need to know, is this public key, is it my public key or not? We don't need to take care about it because we only trust Fusio. As long as Fusio said it is my certificate, then we can trust it.
Okay, that makes sense. So that's how you would be using that. Now, you found a problem. What kind of problem did you find? Let's look at the attack vector that you used, so we can dive into how this attack could maybe potentially start.
Yeah, that's sure. Today. So the example I gave is just a very simple example on how a person, me, to sign a PDF file. But okay, let's go back to the CICD pipeline part. CICD pipeline doesn't have a GitHub account. They cannot do the browser GitHub sign in. But still, cosign gives another way for the GitHub the GitHub CICD workflow to prove itself. It's to use the OIDC token. So if anyone doesn't know, if you use GitHub Action, you can request the OIDC token. The OIDC token is issued by GitHub, and then it has many attributes to describe the GitHub Action run. For example, what is the workflow being used? What is the repository of it? Nowadays, I think many cloud people know that OIDC token because the OIDC token can be used to access the AWS account because we can trust the CI/CD pipeline, and then we can extend this trust to our AWS environment. So we're basically saying, okay, in my AWS account, I open an IAM role, then we can use the GitHub OIDC token to access it. So this is the GitHub OIDC token. Fusio also support using the GitHub OIDC token to get the certificate. So the certificate is basically, in my previous example, the certificate is issued to me, but in this case, the certificate is issued to the GitHub Action run itself. So then that's the tricky problem. If we have a very simple GitHub Action, the GitHub Action has a cosign workflow to sign something, maybe a container image that we have just built. Then we can cross-check, just like the previous example, you cross-check if the PDF file is signed by me. Similarly, we can cross-check if the container image is signed by this GitHub Action. It's very simple. Very simple. But what if we are using reusable workflow? So
what happens if we do that?
The tricky part is if we use a simple workflow, we know that this container image is signed by this workflow. But in a reusable workflow
Of course.
world, we have a caller workflow calling the reusable workflow. In this case, who is actually signing the container image? It would be very confusing. Is it the caller workflow signing it? Or is it the reusable workflow being called signing it? That's the tricky part.
I would guess it would be the reusable workflow that is being called.
Yes, you're right. And that's make the problem because the GitHub reusable workflow doesn't really have a good access control feature. So if your repository is public, your reusable workflow in that repository is not just called by you, but someone else using their own GitHub repository can call it as well. So what my research has been doing is I go to the search engine to search all the GitHub reusable workflow, and then find out what reusable workflow is making use of cosign. Then I try to mimic their repository and directly call their reusable workflow and see how my artifact would be signed. And interestingly, those artifacts, if you look at the cert, you will see it is signed by their workflow. Then there will be the problem.
Okay. Yeah, okay. So the using reusable workflows opens up that hole, and that then means that I cannot trust the signed stuff.
Yes, we cannot simply trust the signed stuff because if I in my repository I built some but maybe just random hello world Docker image, and then I call some repository B a reusable workflow to sign it, and I distribute the container image to you. You verify it. You may think that, oh, this is built by repository B, but actually it's built by me. So we cannot simply trust it.
Okay, so where did you find this? In which repositories did you find that? Maybe let's look at your blog, the blog post that you wrote about this, which made me being interested in it. Let's try to re-explain. Once again, explain the attack that you were able to conclude with the diagram that you have painted over there, right? And then we can, from there, drive into the two repositories that you have mentioned, right? That have had the same issue. Let's see, to bring up your screen.
Yeah. So this is the repository that I have been looking at.
Let's start with the blog post and the and the picture, just to rephrase a little bit. So if you scroll down, I think the best explaining diagram is the one that that attack path diagram. Maybe let's walk through that again, right? And let's make it a little bit more catchy on how can people really understand what happens over here.
So here we can say there are two repository. The one on the left hand side is the victim repository. So it has a build workflow, the green one, basically building some container image based on the source code. And then we call the reusable workflow in the same repository that do the signing itself. This workflow will produce the software itself, which is the container image, and also the signature, which is the certificate issued by Fusio. And you can see the identity is a victim repository here because it makes sense because it's from victim repository. Of course, the signature is from victim repository. But then there is another attacker repository on the right-hand side. It has its own build workflow, which may be building another thing, maybe a malicious software, a Trojan horse, or something else. And then it can, because there's no access control at all on the GitHub reusable workflow, so it can actually call the victim repository signing reusable workflow and ask it to help me sign my malicious software. So this workflow will end up producing, first of all, the malicious software and the signature of the software. But at this time, because the workflow stay in the victim repository, Fusio will issue a certificate that the subject name is victim repository. So if I ask someone to download the software and then tell them to verify the signature, they may think that, oh, this software is from victim repository. Imagine if this victim repository is a very popular, very famous repository, and then I tell the user to okay, you can verify it's from Microsoft, it's from Amazon, it's from whatever famous company, then they may trust it. That's the problem.
So, Richard, now looking at this diagram, I can see that the problematic part of this is really this purple reusable workflow, right? That really kind of makes my repository, I'm the victim repository, and that makes it being attackable. So, what's your approach on how to fix that? What's the best way to avoid that someone uses my workflow, which then has my identity, right? And signs something with it.
So, natively, GitHub doesn't provide the access control and reusable workflow, but actually we can tweak some code to do the access control ourselves. One way to do it is we can look at this pull request, which is I open it to fix one of the vulnerable repository. If you look at the pull request, it's actually very simple. It's just one line of code change. So here you can see the reusable workflow has one step to sign the image, and you can see here they make use of cosign to sign the produced container image. So here, instead of running this flow no matter what, we can add a condition here, is that if the caller workflow is from this repository owner, which is actually their organization, then we will run this step. So imagine if we have an attacker repository calling this reusable workflow, this variable, GitHub.repository owner, will be the attacker. Then this step will not run. Then we can protect ourselves from being used by the attacker.
So if I look at this code change, Richard, it looks like if now I, Johannes, would be able to create a repository in the Bank Vaults organization, I would still be able to sign software that is not related to the Bank Vaults repository.
Yeah, that's true. Right? Actually, my original pull request is to use more specific variables, which is the repository name, which will match this whole repository name. But then the Bank Vaults maintainer asked me, can we change it to repository owner? I don't know the exact reason, but I would guess maybe they have planned to use this reusable workflow in more of their repository. But it's still not a problem, because in order to create a repository under this organization, you need to be a contributor of this organization. And it's only 7 members in this organization, and I think they are all under the same organization. They are all trusted, so I think it's not an issue.
Yeah, I think you're right. At the same time, this opens a question for me around: should GitHub allow me to control who is able to reuse
this is.
Somehow.
Yeah, this is a good call. Right? Actually, I also mentioned in my blog post is that I feel like GitHub didn't really spend a lot of effort on identity management and access control. So this would be my one of my feature requests to GitHub is to control who can use my reusable workflow. Then we can solve many issues that who knows if there's any other issue that caused by reusable workflow being used by other repository. Maybe we just didn't discover, but we may potentially have this problem in the future. So the best way is to implement access control.
Yeah, that makes sense. And that is one possible fix by verifying before the step of signing is executed that you are calling this workflow from the right repository. Now, you said a more prominent repository, which is ArgoCD, that I also recently talked about in my channel because of multiple possibilities to use it, also had a similar issue in their repository. They fixed it in a different way, right? So let's look at how they fixed it.
Before we talk about their fix, I want to show you more about the certificate itself. So actually, if you look at this, this is the record, SIGstore record. This is another component under SIGstore, which is a log on all the signing. So basically, every time someone uses cosign to sign something, it will be logged here. So actually, we can see the signature and the certificate of the code signing signed by the ArgoCD. So here you can see about an hour ago, ArgoCD has signed their image using SIGstore. So we can see this record. You can see the problematic part is here, the subject alternative name, which is the identity. You can see this container image is signed by this reusable workflow. But actually, besides this one, we have more attribute under the certificate that we can use to verify. One of it is the source repository here. So in the diagram I show you, we have the victim repository and the attacker repository. And if we do the same thing, the same attack path again, what we will see in this certificate is the subject alternative name will be the reusable workflow of the victim repository, but the source repository URL will be attacker repository. This is one thing.
Okay.
So before I report the vulnerability to ArgoCD, let's look at how their documentation say the suggestion of verifying the container image. You can see they suggest us to use cosign verify to verify the ArgoCD image to check if it is built by this reusable workflow. But that's it. This is the only criteria. Maybe the second criteria is it built by GitHub? So obviously we need to check, because if it's built by other CICD pipeline, then obviously we cannot trust it. So, but besides, is it built by GitHub? The only thing we verify is it using this reusable workflow? Then we will have the problem that some attacker can use this reusable workflow to sign it. So if we only trust this attribute to verify, it's not enough. So what they end up fixing it is not fixing their code, but fixing the way our customer need to do to verify the image. So their fix is very simple. They add this one. They add this line. It's basically to check the repository. Is it coming from Argo project ArgoCD? If the image is signed by an attacker repository reusing this reusable workflow to sign it, this attribute will be the attacker repository. So ArgoCD is basically pushing the responsibility of verifying the image, this responsibility, to the consumer, rather than fixing their CI/CD pipeline. So today,
okay, that's an interesting take. It's an interesting comment, Richard, and it's very interesting because I had an ArgoCD maintainer on my channel just a few weeks ago, and Carlos and I gave an introduction into Kubernetes as a whole, right? So I'll mention this to him as well and see.
Yeah, actually, if you see the fix is very simple, just a one-line code. I don't see why they shouldn't do it.
Yeah.
Yeah.
Makes sense. Cool. But at the moment, as you say, right, ArgoCD is kind of fixed. Bank Vault is also fixed. Have you thought about about identifying other vulnerable environments or repositories? Did you kind of look at how you could find
actually, in my blog post, I mentioned several repositories that is maybe vulnerable, but they are not yet vulnerable. The reason is they suggest the consumer to use the same way as ArgoCD to verify their image. But then I cannot call their reusable workflow for some reason. Some maybe they didn't expose the secret parameters in their reusable workflow, so I cannot call them. Because if you don't know, if someone don't know, if you want to call the reusable workflow across different organizations, you need to explicitly mention what secret to pass in, but they choose to use inherit, so I cannot call them. But it's just a matter of when GitHub changed their logic of cross-organization reusable workflow, then maybe one day I can call the workflow, then they will become vulnerable. Yeah.
Okay, makes sense. Cool. Richard, I think that at least from my notes, we went through most of the content that we had planned to do. Thank you so much for taking the time. Let's stop your screen share. And we had thought about what would you advise for people to do, right? So what is important from a security practice perspective? What you would want to give the audience?
Sure. So first of all, is it's a very basic thing. Is you need to know your reusable workflow can be called by other repository. Actually, not just reusable workflow, but all the workflow or the source code. So first of all, you simply don't put the secret into your workflow. This first one. The second one is more specific to this topic, is the OIDC token. So I see many people start to using OIDC token, but what most people don't do is to really study the documentation on what is the OIDC token actually is. There are many attributes under the OIDC token. What does it actually mean? One of the example is back in, I think 2 years ago, when people start using the GitHub OIDC token to authenticate to AWS, they just use the AWS console to create the IAM role. The default is you need to trust the issuer. Is it from GitHub? And the second one is the audience. That's it. Just these two criteria. But if someone really serious and go into the GitHub documentation and look, then they will see the problem. The issuer is always GitHub. So if you have a IAM role that trusts this, only trust the GitHub action, that means all the GitHub user can log into an AWS account. So you may think, okay, there's another attribute. We can use it as a condition to control who can assume our IAM role. But again, if you look at the GitHub action documentation carefully, the audience can be customized. So actually, if you use it as a condition, it's just like guessing a password. So I can create a GitHub action and then just brute force the audience and see, can I assume your IAM role? So this is really important. When you use OIDC token, look at the vendor's documentation and see, first, what does it mean? And second, can it be customized? This is very important.
Cool. Thank you. And that would mean that the customization would be something that you would want to do or would want to avoid?
We would want to avoid, because an attribute can be customized. It's just everyone can impersonate you.
Yeah, makes sense. Cool, Richard. Thanks a lot. Where can people find more about you, and how can they reach out to you if they have additional questions or if they would potentially get some advice from you on how to fix their problem in their pipelines?
Yeah, sure. I'm on LinkedIn and Twitter. My handle is RichardFan1126. And also my blog post is on blog.richardfan.xyz.
And do you prefer Twitter or do you prefer
I would prefer LinkedIn. Twitter is more casual. So if you have some more serious question about security or something, LinkedIn would be better.
Cool. Then I will link that to the show notes when we publish this recording. Any last final words, Richard? Anything you want to share before we close the recording?
Yeah. CICD pipeline security is very important. So just to make sure you do the right thing. Yeah.
That is true. I can also only resonate with you on that one. So that is really important. And still a bunch of people still think that CI/CD is just something that you need to be pushing something to production. As you know, I think CI/CD should be the core of every software development. And I think that's what you're also saying. You need to protect your CI/CD pipeline in the same way that you protect all other parts of the software. I think that is pretty important. Thank you so much, and looking forward to see you in person soon, and to then also have a lot of fun together. And thanks again.
Yeah, thanks, Johannes. Thanks for having me. Bye-bye.